Okay, so in the previous example we forced the states to go like the diagram, but what I'm going to think about this time around is I'm just going to think about having 4 states, and the states are just going to be a counter, right? And they're going to reset to 0 once it reaches the 4. And then in this state we're going to output 0, 0, 0. In this state we're going to output 0, 0, 1. In this state we're going to output 0, 1, 0. And in this state we're going to output 1, 0, 0. So let's see what that looks like. Okay, so our present state, next state, it goes 0, 0, 0, 1, 0, 1, 1, 0, 1, 0, 1, 1, 1, 1, 0, 0. That's what our present state next state is. We only need 2 devices. Again, I'm going to use I'm going to use D flip-flops. And here, going from 0 to 0, we need a 0. 0 to 1, we need a 1. 1 to 1, we need a 1. And 1 to 0, we need a 0. And then 0 to 1, we need a 1, a 0, a 1, and a 0. Okay, so now we only have 2 bits, so our table is going to be, all right, just a square. So 0 and 1 and 0 and 1, and our D0, so this is our D0 one. And we just get 0, 0 is a 0, 0, 1 is a 1, 1, 0, that should be a 1, not a 0. 1, 0 is a 1, and that's a 0. And then let's do the other one. Hopefully we can copy it and paste it. And this time we'll do that color and that one. And now we need a 1 there, and a 0 there, and then a 1 there. Okay, so this one doesn't really help much, but what you should see is that for that one, when you get a diagonal like that, right, there's a diagonal, that usually means there's an exclusive OR. So we could implement that as A exclusive OR B, and obviously this one doesn't depend on A, so it's just B bar. Okay, and then our D flip-flops, again we'll have our clock into our A flip-flop, and we'll have another B flip-flops. We've only got 2 flip-flops. Again, we'll connect up those. Here's our A, and remember we also get an A bar usually for free. And here's our B and our B bar. Our B bar is our D1. right? So we should be able to just connect that up into our D1 input, and here's our D0 input, and our D0 input is just the exclusive OR, so we can write an exclusive OR between A and B. Okay, that is our counter, but we still haven't dealt with the outputs, right? So we need to figure out how the outputs work, and let's just do another table. We're going to need 5 by something like that, right? So here's A, here's B, and here's our output 1, output 2, output 3, and we've got 0, 0, 0, 1, 1, 0, 1, 1, and output 1, so 0, 0, 0, 1, 0, 0, 0, 1, and then 0, 0, 1, 0, and then 0, 1, 0, 0. Okay, and so output 1 is nothing more than AB. Output 2 is nothing more than AB bar. And output 3 is nothing more than A bar B. Okay, so we should be able to draw that with 3 AND gates. Okay, so AB is A, and let's just bring B down from here. Right, so there's our output 1, and then A, B bar, maybe we can bring that one across there, and just bring B bar down to there. There's our output 2, and A bar, it's going to be a little ugly, but I'm just going to hop there, and maybe hop there. There's my A bar, and B, I think I brought B down there. I don't know, it might be just as easy to come from this direction this time. Right, and there's my O3. So now we have 2 circuits that sort of implement the same thing. This one, which actually I think is a little simpler, except we need a 3 input AND gate to get our A bar, B bar, C bar. Or this one, where we only need 2 D flip-flops, and but we need 3 2 input AND gates. And which one we're going to use is going to be up to, actually we also need an exclusive OR gate in this one. So we'll have to look up, I think this one will require 3 chips, right? The exclusive OR gate, the a dual D flip-flop, which is I think a 7474, and then a quad AND gate to get our 3 AND gates. Whereas this one will require also 3 chips. I think we need 2 7474s to get our 3 D flip-flops, because they're only dual flip-flops, the 7474. So 3 versus 3. It's a much of a muchness. Anyway, that's the two different approaches to sequential design. One of them forcing the states to change the way you want them. The other one to have a simple counter and only decoding the count to give the outputs that you want.